My favourite thing about the job is that we can see that the tests we do result in better engines, lower emissions, quieter, safer. My name's Ben, I'm a design engineer. I work at a company that designs test rigs for various aerospace customers, and I design test rigs for aerospace applications. When I'm not working, I've always enjoyed sports, so from a young age been on football teams, also played American football for quite a while. I like team sports, but I also like mountain biking. So I go up to Scotland quite often, do mountain biking up there, you know, outdoorsy stuff. Yeah, outdoors, anything active, love doing that. I don't think anybody would have pointed at me when I was a young kid and said, he's an engineer in the future, not even as a teenager. If you ever looked up at an aircraft and thought, you know, what the hell's that doing up there? How does that work? You know, that was me when I was a kid. I lived near Manchester Airport, so every day I'd see the planes coming and going, and that was a big thing, you know. My dad worked for British Airways. He wasn't in a technical role, but, you know, those sort of loose connections were there. Bit of an all-rounder in terms of there wasn't specific subjects I was strong at compared to others. So, you know, I was interested in history at school and maths and science as well. My GCSEs, I did the double science. Of course, the core subjects, maths, English, IT, history. At A-level, I studied maths, physics, history and business. In my second year, I dropped the business, but at that point, I still didn't know what I wanted to do. To be honest, for a long time, I wasn't planning on going to university. A friend of my mum's, who was a teacher, said that I should, you know, he knew me quite well. He said, yeah, you should go. So I looked at the list of courses, and yeah, the aeronautical engineering kind of popped out to me. No one in my family was really an engineer. To be honest, I didn't really understand what engineering was until I was 18, 19, and already on the degree. I decided to embark on that degree because a lot of the challenges we've got in terms of emissions and climate and the rest of it, and I think that you can have an impact by designing better products. I was the first one from my family to go to university. My mum and dad didn't go, so it was all a bit new to us. I remember telling my dad that I was going to study engineering, and he said, "Oh, you don't want to do that." People sometimes have misconceptions of what engineering is. He didn't really understand what it was and what it could lead to. A lot of the time people think, oh, an engineer is a nerdy guy who sits in the corner with, you know, pressing buttons on a computer. It's a misconception. Nor is it a grease monkey who's going to have his hands dirty with oil and muck all day. Those people are in the team, but the team's full of lots of different people. When I started university, after 4 weeks I wanted to quit. I wanted to go home. Massive culture shock. I thought, what the hell's this course I've started on? Don't understand any of it. It's not what I thought it was. But I think that's actually a common thing for people when they go to university, because you're going to meet people from all different backgrounds from all over the country. It's just a melting pot, and it is a culture shock. But I think you've got to just ride that through. 6 months into the course, I was flying. So, you know, by that point, I'd really sort of started to realise that, hold on a minute, I can actually, you know, do this. And 12 months in, I was totally, yeah. And when I completed the degree, the Careers Centre at the university, they had a little job board, and this job was on there for a graduate engineer. I joined the company, and I've been working there since. One of the things I love about engineering is you get to work with everyone in all different parts of the economy. So even at our company, we've got people from all over the world. We've got people who've come up through apprenticeship routes. We've got people who've studied PhDs, you know, people from America, India, Mexico, Spain. You're working as a team to deliver an end goal, and you're all sort of bought into that idea. It's a team game. It kind of matches sports in that way. No one person can design a 747 jumbo jet by themselves, so there's a space for everyone. I design mechanical assemblies, electromechanical assemblies. So that could be I'm designing physical components. It could be I'm helping program some software. It could be doing some drawings of assemblies or components that we're going to make that are going to go to manufacture. What I'm holding here is a component that I designed, which is on a combustion test rig. It's 3D printed in metal, It's part of a combustion test rig, so it takes emissions gases from the back of an engine in this side and goes out this way. The reason it's 3D printed is the bores have to be curved. So it's very difficult to make that using old-fashioned conventional methods. So we printed it, and then we polished some of the bores using different methods, and then we cut it up to see if the polishing had worked. So that's an example of a component that I've designed, 3D printed in metal, and it's used on a combustion test rig to measure the emissions gases from an engine. Engineering is project-based, so there's always a project that I'm working on, and that project has a start, a middle, and an end. So at the start, your customer will give you a list of requirements, things that they want. You have to figure out how you're going to give them that. You go through a sort of concept phase where you'll do the sketches, you'll start to think, how might I actually make this product? How might we deliver this? So in that stage, I would be modelling components in 3D, so drawing them in 3D on a computer, making predictions about how they will perform, so how strong are the components, how long are they going to last. And then we go into the manufacture stage where those plans that with the blueprints is the old-fashioned term, will progress into manufacture. And we're into the assembly stage where I would be, so if I'm the lead engineer on a project, I would be coordinating that build effort, seeing all the parts come together, and these parts could be coming from all over the world. That test rig then has to be delivered to the final test facility, and then we actually run the tests, and that can be a really cool part of it too. They can be quite dramatic. So one test I've been involved with is called the blade off test. We spin an engine up really fast, and then we release one of the fan blades at the front, purposefully detonate a little charge at the root of the blade, and watch the blade come off in full speed. We've got cameras on it and everything, and we're looking to see what happens when that blade gets released. Does it penetrate through the casing of the engine, making sure it's safe? So when you press that button and it goes boom, it's quite funny because the whole building shakes. It's really loud, and people that are coming out of the car park must think, well, I wonder what that was. The space sector is growing very quickly. There's a massive shortage of people studying these technical subjects. There's a lot of jobs out there. The jobs are well paid. I think it's a fun job. It's always different, no 2 days are the same. I don't know why everyone doesn't do it.